Hi guys, welcome to Chakri Science Academy. In today's session, we have come up with some more competency-based questions. If you remember, in the last video, we have discussed competency-based questions from the chapter Alcohol, Phenol, Ethers. And after all your demand, I have come up with some more questions of this type. And if you haven't watched it yet, make sure you watch it. You will find the link in the description box below. Now let's see the question. I'm going to tell you how to approach these type of questions. I'm very sure after this video, you will find very confident in such type of questions. So in this question, it says two compounds A and B have molecular formula C2H6O. So first of all, for such type of questions, you have to write the information in the form of a flowchart. So let's do that. So we have two compounds A and B, and they have the same molecular formula. That means they are isomers, C2H6O. Now it says the A gives, now A, if you react with HI, it gives you alkyl iodide and it gives you water. And if you react the B with HI, it says it gives alkyl iodide and alcohol. So first of all, we need to understand that we need to think of functional group which contains one oxygen only. So it could be aldehyde, it could be alcohol, it could be ethers. So in order to understand why it can't be aldehyde or why it can be alcohol or what exact compound it is, first we need to check about the double bond because we know aldehyde contains a double bond. So for that we will use the formula double bond equivalence DBE that says carbon minus hydrogen by 2 plus nitrogen by 2 plus 1. So this is to check whether there is a double bond or not. So we can understand whether it is aldehyde or not. So based on the formula, we can fit everything, the values. So carbon is 2 minus 6 by 2. Nitrogen is not there, so we will ignore this part. Plus 1. So what do we get? 2 minus 3 plus 1 is equal to 0. It means one thing is very clear, there is no double bond. So possibility of aldehyde is ruled out. So we can think of either it could have a alcohol or ether, or it could be both. So based on the given information, you can see there are two 2Rs on reaction with HI. So it must be a ether. So compound B, based on the formula, two carbons, it has to be a dimethyl ether. So it means our B substance is CS3O CS3. And when it undergoes reaction with HI, what it will form? It will form CS3I plus it forms CS3OH. So we have got our B. Similarly, A has to be a alcohol because when alcohol reacts with HI, it forms alkyl iodide and H2O. So it fits everything. So 2. So it must be a ethyl alcohol. And when it reacts, what it will form? Ethyl iodide, CH3, CH2I, and H2O. So I think we have got our compound A. We have got the products. We have got B as well. So let's see the next question. So in the second question, it says compound A, C4H10O, is found to be soluble in acid, sulfuric acid. So let's write the information. We have substance A and the formula is C4H10O. Now what's the information given? It's soluble in sulfuric acid. So in the H2SO4, it is soluble. Second, it says it does not react with sodium or potassium permanganate. It means it will not undergo oxidation with sodium or potassium permanganate. Okay, sodium or potassium permanganate. There will be no oxidation. Now the question says on heating with excess of HI, it means if you heat this with HI in excess. So it says it forms only one type of alkyl halide. So only one type of alkyl halide will be formed. So we need to understand what is A. Again, it has a one oxygen, so it can be alcohol also, it can be ether also, it could be aldehyde. So first of all, to exactly understand what compound is this, first find the double bond, whether the double bond is there or not. So DBE. So we'll apply the same formula. So how many carbon? There is 4 carbon. Minus total hydrogen 10 by 2 plus 1. So you can see 4 minus 5 plus 1, double bond is 0. That means the possibility of aldehyde is ruled out. Now we have option of alcohol or it could be ether. Now it can't be alcohol because it says it will not oxidize with sodium or potassium permanganate, but alcohols do oxidize. So it must be ether. So by this information, we understood it must be an ether. And we know on the ether, when we put excess of HI, it forms alkyl halide because the alcohol which will be formed will also change into alkyl halide. So let's write a reaction. So 4 carbon, so it must be a diethyl ether. So write it down. And why diethyl ether only? Because it says only one type of alkyl halide is there. So that is why. So let's write the formula. So formula will be CH3, CH2, O, CH2, CH3. So when you react with excess HI, we'll take 2 HI because two alkyls are there. Okay, dimethyl ether. So we will see you will get 2 of CH3, CH2I. So it's pretty clear. Ethyl iodide, we are forming only one type of, because what happens when you take in excess? So the byproduct which we have seen in the previous reaction, the alcohol will also change into alkyl halide, okay, because you are taking this in excess. And because only one type of alkyl halide is formed, so it must be a diethyl ether. It will not be a branched ether, okay. We will take the diethyl ether. So let's see the next question now. So in the third question, it says an organic compound A having molecular formula of C2H6O. Let's write the information. This question looks big. So compound A is there and the formula is C2H6O. Now let's write the information given. So it says it reacts with sodium to give a compound B. So when you react this with sodium, it forms compound B with the liberation of a hydrogen gas. Okay. Moreover, it says it gives yellow compound C on reacting with iodine and NaOH. It means if you react this with iodine and NaOH, it forms C and this is yellow. So I think by the reading the question, we have understood what C is. C must be a iodoform, that is CHI3. It must be a iodoform. Why? Because I2 and NaOH is a reagents used in iodoform reaction, and that's how it forms a yellow substance iodoform, and that is why it forms iodoform test. So now we have understood A must be something which gives positive iodoform test. Okay. Now apart from that, let's read the question more. It says when it is heated with concentrated H2SO4 at, so there's another reaction which says if you are heating with concentrated H2SO4. And what is the amount of heat? 413 Kelvin. Okay, precisely. So it gives you D. And the formula of D is C4H10O. Okay, so by looking at this reaction, it's a very famous reaction discussed in the NCRT that when you are carrying out a dehydration of alcohol exactly at 413 Kelvin, it gives you ether. So, but anyways, we'll go step by step. After that, it says that on reaction with conc HI, so another reaction is if you react with concentrated HI, okay, at 373 Kelvin, it forms E. Moreover, the question is saying that B can also be obtained when B is heated with E. So when you react, heat the B with E, you will get D. So they're asking you to identify A, B, C, D, E and complete the reaction. So let's understand what A possibly could be. So first of all, A can be a aldehyde also. Okay, alpha methyl ketone group. Okay, alpha methyl ketone. It could be a ketone also because why I am repeating again and again alpha methyl ketone, because that is a thing we check for identification of iodoform test. So there is a possibility of alcohol also because there are alcohols who give iodoform test and there would be aldehydes who have alpha methyl ketone group. Ketones also give it. So how do we understand? How do we identify? So for that, let's find the DBE first. So let's see if there is a double bond or not. So with the given formula C2H6O, let's find out. So there are 2 carbon minus 6 hydrogen by 2 plus 1. So 2 minus 3 plus 1. So we got it 0. It means the aldehyde and ketone chances are ruled out. It must be alcohol and only ethyl alcohol gives iodoform test. So take a note. Only ethyl in the alcohol family, only ethyl alcohol gives the in the 1 degree alcohol, you need to write in among 1 degree alcohol, only ethyl alcohol gives positive iodoform test. So you need to know among 1 degree alcohols, only and only ethyl alcohol. And now you might ask me a question, sir, why you mentioned 1 degree alcohol? How you thought it's 1 degree? Because only 1 degree alcohols are enough reactive that when it reacts with active metals such as sodium, it can remove the hydrogen gas. Otherwise, 2 degree and 3 degree alcohols are not so reactive because of increasing of plus I group. And we know plus I group decreases the acidic nature. So that is why I said 1 degree alcohol, it must be by looking at this reaction, and only ethyl alcohol is there among primary alcohols. And why it is so? See, you need to see who can get oxidized and form alpha methyl ketone. So if you oxidize ethyl alcohol, it will form, when you oxidize the ethyl alcohol, what you will see, you will get CH3CHO, acetaldehyde, and you can see there is a alpha methyl ketone. That is why I said only ethyl alcohol can give positive iodoform test among 1 degree alcohols. So let's go ahead now. So we have understood that this is our nothing but ethyl alcohol, C2H5OH. Now reaction becomes easier. First of all, what happens when you react with sodium? So the B substance will be C2H5O minus Na plus half H2. Okay, we got the B also. This is our B. We have got C also. Now let's understand D. So we know, I was talking about this. It's given in NCERT. It's a very important reaction that when you carry out a dehydration exactly at 413 Kelvin, what you will get? You will get the ether. And if the temperature goes above 443 Kelvin, then what you get? You will get alkene. Okay, so because the temperature is low, it favors nucleophilic substitution reaction, and if the temperature goes above 443 Kelvin, then it favors elimination reaction, and due to elimination reaction, H2O will be removed and alkene will be formed. Keep that in mind. Now let's move ahead. So which ether will be there? You can see it's the C2H6O is there, so it must be a but see here, it says there is 4 carbon. So for that, we can say the reaction will be 2 of C2H5OH. And when you are heating it with acid at 413 Kelvin, so you will get CH3, CH2, OCH2, CH3. So this is our D. You can see, just to confirm, the formula is given and this is the reaction. Remember, if temperature is low, it favors SN2 reaction. Nucleophilic substitution reaction is happening here. And you might be wondering why alkene has not formed. So for alkene, you need a higher temperature because nucleophilic substitution reactions are favored at low temperature. When you do higher temperature, 443 Kelvin, then it will be elimination reaction, and due to that, alkene will form. So at 413, okay, under same condition. Now, so we have got the D also. Now let's learn how, what will be the E. So on ethyl alcohol, when you put concentrated HI, we know what this will form. It will be alkyl halide. So this will be C2H5I plus H2O. So this will be forming alkyl iodide. Okay. Now, after that, the next, just to confirm our B and E, to check whether it's giving D or not. So our B is sodium ethoxide. I think it's a Williamson synthesis. Sodium ethoxide and alkyl iodide will form a ether, which is nothing but D. But still, let's write the reaction. So just to confirm that, the B we will take is sodium ethoxide. So C2H5ONA reacts with E. And what is our E? E is alkyl iodide, that is C2H5I. So you check, when you heat them, it forms ether. It's a Williamson synthesis. So here you will get, so NaI will be removed, minus NaI, and you will be getting the same substance, C2H5 and C2H5 dimethyl ether. So you will get the same compound. That means we have got the all the compounds. So let's see the next reaction. So in the fourth question, it says a compound A with molecular formula C4H10O. So let's write down the information. So there is a compound A with the molecular formula C4H10O. Now it says it reacts rapidly with sodium. So this reacts with the sodium rapid. And it also says it is very slow to Lucas reagent. So when we try ZnCl2 plus HCl, which is called as Lucas reagent, so then it is very, very slow. Moreover, the question says A when it is treated with hot concentrated H2SO4. So when you are treating with H2SO4 concentrated, it says it gives compound B. So our B is having a formula of C4H8. C4H8 means it's a alkene. All right. Now it says upon hydration with aqueous H2SO4, it means another reaction. If you carry out acid hydrolysis, because it says aqueous hydration, hydration means adding of water, it forms compound C, and the molecular formula of C is the same as A, C4H10O. It means the A and C are isomers. Moreover, it says the compound C is almost inert. Now C is totally different with A. It's just opposite. So C is inert. C is inert with sodium metal and it is fast with Lucas reagent. With Lucas reagent, it is fast. So question is talking about Lucas reagent, so we don't have to think much about it. What is the compound A must be? It must be alcohol. Now, which alcohol it will be? You can see here, first of all, it is slow to Lucas reagent and it gives a fast reaction with active metal like sodium. So it has to be a 1 degree alcohol. It must be a 1 degree alcohol because 2 degree and 3 degree alcohols are quite fast for Lucas and they don't tend to react with active metals like sodium because their acidic nature is low. Okay. And for 3 also we are very clear it must be a 3 degree alcohol because it is very fast to Lucas reagent and it is inert to sodium. So we know 4 carbons are there and it's a 3 degree alcohol. So the only option is it will be a tertiary butyl alcohol. You all can check with 4 carbons and it is 3 degree, it has to be a tertiary butyl alcohol. So we have got our compound C. All right. See, Lucas reagent is based on carbocation intermediate, and we know rate of reaction is directly proportional to the stability of intermediate. Here, the intermediate is carbocation, and we know the stability of carbocation is highest in 3 degree, then 2 degree, and then 1 degree, and that is why Lucas reaction is very fast in 3 degree alcohols. So take a note of this. Now we have to go in a bit of reverse to get our B substance and A. See, so in B we know it's a elimination reaction. How we would have got C from the B by doing elimination. Like I told you, it's sulfuric acid heating is there and it's forming alkene. It must be a elimination reaction which is carried out at 443 Kelvin. In the previous question, I told you if you do this at 413 Kelvin, it will be a nucleophilic substitution reaction and it forms ethers. But here it is C4H CnH2n, CnH2n, it must be a alkene. Okay. So how elimination reaction, led to this? So we have to go in a bit of reverse. So the alkene we have to get and understand we are getting it from 1 degree alcohol. So sum total of all that, what you have to do, you have to remove this OH and you have to remove one hydrogen. Okay, because when you would have carried out the C, what you have done, you have added the H2O. So remove OH and remove the H and put a double bond. It will give you your alkene, C4H8. So our alkene must be this. So I'm removing one hydrogen here, so it becomes CH2. Putting a double bond, remove the OH, and these two are the CH3. You can see this. These two groups are as it is. From here I have removed the hydrogen and from here I have removed the OH. And because of that, in between there is a double bond. So this is our B. We have got a reaction going in reverse. So this is our B substance. You can see that C4 and H8. There are 8 hydrogens and 4 carbons. Now the question is 1 degree alcohol and how we got 1 degree when we did the heating. So again you have to go in a reverse reaction because from here you have to carry out from A to B, which is basically a elimination reaction. Elimination reaction means when we did elimination, we got this. It means you have to add H2O. We are going in reverse. Then only we can get our A. So it means when you add H2O, you add the negative part on the higher degree carbon. Okay, that is the Markovnikov addition we follow, Markovnikov rule, and the hydrogen will go to the other. So our answer has to be a this CH3, then this carbon who gets the OH, I mean this carbon who has the CH3, then you have this carbon, you can see that, and you have OH. So you can see this must be our answer. So this is your isopropyl alcohol. It is a 1 degree alcohol. So we have got in reverse. So this is our A. In this A, when we added H2SO4 and heated, it formed the alkene. In alkene, when we added as H plus H2O, hydration, it forms C. So this reaction we have got in a reverse and got our product. So let's move to the next question. So in the last question, you can see it says alcohol A with molecular formula C4H10O on oxidation with acidified potassium dichromate, it gives you BC4H8O2. Then it says compound A when you are dehydrating with concentrated H2SO4 at 443 Kelvin. Now this temperature is very, very important and it gives compound C. Now treatment of C with aqueous H2SO4, it gives D, C4H10O. Now if you see D and A have the same molecular formula given, that means they are isomers. Question also says that D is the isomer of A. Now compound D is resistant to oxidation, but A is easily oxidized. So you have to identify A, B, C, and D with the given reaction. Also, the question is asking you name the type of isomerism, the isomerism which D and A are. So I'm very sure after going through this session, you will be able to find these questions easy. And don't forget to give your answer in the comment box below. And keep following Chakri Science Academy for more such videos. Bye bye for now.